Hi everyone, welcome back to channel. In this video, we are going to discuss numerical questions from current electricity chapter. These numericals are very important for 5 marks questions from the third chapter, that is current electricity. Let's get started. The first question, two identical cells either in series or parallel combination gives the same current of 0.5 ampere through external resistance of 4 ohm. Find EMF and internal resistance of the cell. So let us consider the first situation. There are two identical cells either in series or parallel. Let us consider first situation. Okay, if those two cells are connected in series, let two cells connected in series. Therefore, equivalent EMF of combination E equivalent is equal to, the formula is N into E. There are two number of cells, so that equivalent is equal to 2E. So E equivalent is equal to 2 into E, where N is the number of cells. Similarly, equivalent resistance R equivalent is equal to N into R, where R is the resistance or internal resistance of the each cell. So where N is the number of cells, so that 2 into R equivalent. Then we know the formula for current. Current I is equal to, in terms of EMF, E equivalent divided by capital R plus R equivalent. In the given question, the same current is flowing through the each combination, that is 0.5 ampere. So that current is 0.5 ampere is equal to E equivalent divided by R plus, E equivalent is equal to, let us substitute, E equivalent is equal to 2E and R equivalent is equal to 2R. Let us say this is equation number 1. Similarly, for the second case, let us consider two cells are connected in parallel. Let two cells are in parallel. Then, therefore, E equivalent is equal to E only. When n number of cells, n number of identical cells connected in parallel, the equivalent EMF is equal to EMF of one of the cells, that is E only. Then R equivalent is equal to R divided by N. Therefore, current I is equal to, the formula is E equivalent divided by capital R plus R equivalent. This can be written as I is equal to, look at the question, the current is same in each combination, so that is 0.5, current is 0.5 ampere, E equivalent is equal to E divided by capital R. They given capital R value 4, so that 4, in this equation also let us substitute 4. 4 plus R equivalent, in this case R divided by N means 2. Okay, let us write one more equation. 0.5 is equal to E divided by 8 plus R divided by 2. These two can be written in the numerator. Let us say equation number 2. Look at the equation number 1 and 2. Left hand side. In both equations, left hand side is equal 0.5, 0.5. So that equate the right hand side. Then we will get EMF. We have to find out EMF and internal resistance. Okay. And let us see how to simplify these two equations 1 and 2. Let me erase this one. This is the first equation and this is the second equation. Okay. The first equation is 0.5 is equal to 2E divided by 4 plus 2R. Let us write right hand side only. Okay. From 1 and 2. From equation number 1 and 2. This can be written as 2E divided by 4 plus 2R, equation number 1 is equal to, in equation number 2, right hand side, 2E divided by 8 plus R. 2E will get cancelled out. This will become 4 plus 2R is equal to 8 plus R only. Okay. Let us write this R on left hand side. This will become 2R minus R is equal to 8. This 4 will become minus 4. Okay. R is equal to 4 ohm. Okay. So internal resistance of the each cell is 4 ohm. Substitute this 4 ohm in equation number 1 or equation number 2. Let us write in equation number 2 only, no problem at all. So if you substitute this R value in equation number 2, okay, substitute R is equal to 4 ohm in equation number 2. 0.5 is equal to 2E divided by 8 plus R is equal to 4. Okay, this will become 12. So 0.5 is equal to 2E divided by 12. By the cross multiplication, 0.5 into 12 is equal to 2E. 0.5 is half into 12, that is 6. 6 is equal to 2E and E is equal to 6 by 2, that is 3 volt. So internal resistance EMF is 3 volt and internal resistance is, that is 4 ohm. This is very important for the examination. Try to practice this. Next question. A battery of MFE and internal resistance R gives a current of 0.5 ampere with an external resistor of 12 ohm. When external resistor is 12 ohm, the current in the circuit is 0.5. Okay. So what we need to calculate? Internal resistance of the cell and EMF of the cell. This numerical also very similar to previous one. Let us write. We know that current in the circuit, current I is equal to formula E divided by capital R plus small r. So apply this formula for the first situation. What is the first situation? When external resistor is 12 ohm, the current is 0.5 ampere. So that current is 0.5 ampere is equal to, we don't know E value, we will find out that one, E divided by capital R is 12 ohm and small r also we don't know, small r. Okay, let us say this is equation number 1. Okay, case 1 for case 1 and case 2 for case 2. Current is, look at this one, and current of 0.25 ampere with an external resistor of 25 ohm. Current is 0.25 ampere is equal to E divided by external resistor is 25. External resistor is 25 ohm. So that in this case external resistor 25 plus R. This is equation number 2. Okay. Similarly, solve the equation number 1 and 2. Okay. So before going to this one, let us multiply this equation number 2 with 2, then we will get answer easily, right? So 2 into 2, let us do this one, 2 into 2, that will implies 0.25 into 2, this will become 0.5 is equal to 2E, you have to multiply with 2, entire equation, 25 plus R. Okay, look at this one, equation number 3. Observe equation number 1 and equation number 3. Left hand side is equal 0.5, 0.5. So we can equate the right hand sides. Then we will get the R value and E value easily. Okay, if you simplify like this, we will get decimal point. That may take a lot of time, right? So from equation number 1 and 3, from equation number 1, 3, left hand sides are equal. Equate the right hand side. That is E divided by 12 plus R is equal to 2E divided by 25 plus R. 2E divided by 25 plus R. E will get cancelled. Okay, by the cross multiplication, we will get 25 plus R. There is a 1 into 25 plus R is equal to 2 into 12 plus R. Okay, 2 into 12 plus R, 1 into 25 plus R. So this can be written as 25 plus R is equal to 12 into 2, 24 plus 2R. Okay, write 24 on left hand side, that will become minus 24, and write these R to the right hand side, 2R minus R. So this will become R is equal to 2R minus R, 25 minus 24, 1 more. So if you follow this method, we can solve easily. Otherwise, if you cancel like this only, you will get a decimal points. Okay, but final answer is 1 only. Substitute this R value in equation number 1 or equation number 3, we will get E value. Okay, this is the solution for question number A, question number 1, and question number 2, EMF of the cell. Substitute the R value at this place in equation number 1, we will get R. Okay, from equation number 1, R substitute. R is equal to 1 ohm in equation 1. In that case, 0.5 is equal to E divided by 12 plus 1. 12 plus 1 is equal to 13. By the cross multiplication, 0.5 into 13 is equal to E. 13 into 5, 65. So that this will become 6.5 volt is equal to E. So E is equal to 6.5 volt. EMF of the cell is 6.5 volt and internal resistance of the cell is 1 ohm. Right? R is equal to 1 ohm and E is equal to 6.5. And this numerical also very important. The next question is, the two cells of EMF 3 volt and 4 volt and internal resistance 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction through external resistance of 10 ohm. Then we have to find the potential difference across 10 ohm. Let us consider this is the first cell. EMF of the first cell is 3 volt and internal resistance is 1 ohm. Internal resistance 1 ohm. And EMF of second cell is 4 volt. Internal resistance is 2 ohm. And external resistance is 10 ohm given in the question. You have to find the potential difference across the external resistor. Right? For that one, we should calculate the current in the circuit. Current into resistance will give the potential difference across the resistor. So that this cell sends a current in this direction, this cell sends a current in this direction, these two cells send the current in the same direction through the 10 ohm resistor. They given that condition in the question. Let us say E1 is equal to 3 volt and E2 is equal to 4 volt. They given in the question. R1 is equal to 1 ohm and R2 is equal to 2 ohm. And external resistor capital R is equal to 10 ohm. Okay, those two cells are connected in parallel. They given in the question connected in parallel. So find the equivalent EMF of the combination. So E equivalent is equal to, we know the formula E1 R2 plus E2 R1 divided by R1 plus R2. By using this formula, we can calculate E equivalent. E equivalent is equal to E1 value 3 and R2 value 2 plus E2 value 4 and R1 value 1 divided by R1 plus R2 1 plus 2. This gives 2 into 3 6, 6 plus 4 divided by 3, that is equal to 10 by 3 volt equivalent EMF. Then current in the circuit. Let us consider total current I. Current I is equal to formula E equivalent divided by R plus R equivalent. So where R equivalent is equal to R1 R2 by R1 plus R2. Substitute the value in this equation. Let us find the current. Current I is equal to E equivalent is 10 divided by 3 total divided by R. R means capital R 10 plus small r equivalent. Look at this one, small r equivalent is equal to, one formula is there, R equivalent is equal to R1 R2 divided by R1 plus R2. So R1 is 1, R2 is 2, 1 into 2 divided by 1 plus 2, this will become equal to 2 by 3 ohm, small r equivalent. Okay, this is 2 by 3, take the LCM, 10 by 3 divided by, this will become 10 into 3 30, 30 plus 2 32, 32 divided by 3, 3 will cancel out and I is equal to 10 by 32 ampere. Then what is the question? Find the potential difference across 10 ohm. So potential difference across 10 ohm resistor is V is equal to formula, V is equal to I into R. So I into R, I means total current, this one, 10 divided by 32 into R means capital R is 10, so 10. This will be equal to 100 divided by 32. Okay, if you calculate this value, V is equal to, you will get 3.125 volt. Potential difference across 10 ohm resistor is 3.125 volt. This model is also very important. Let us see the next question is very similar question. Look at the question. Two cells 8 volt 1 ohm and 10 volt 2 ohms are connected in parallel such that they sense current in the same direction through an external resistance of 20 ohm. Look at the first one. This is the, let us consider this is first cell. EMF is 8 volt and internal resistance 1 ohm. And this is the second cell, 10 volt and internal resistance 2 ohm and external resistance is 20 ohm. These two cells are connected in parallel. They given the question parallel. so that they sense current in the same direction through external resistor. That means these two cells send the current in the same direction through external resistor, so that these two cells sends current like this. Okay, this is I1, this is I2. I1, I2 meet together and flow as total current I. Okay, this is the circuit diagram. What we need to find the current and potential difference across 20 ohm. Okay, we know that when the cells are connected in parallel, equivalent EMF is E equivalent is equal to formula E1 R2 plus E2 R1 divided by R1 plus R2. Then let us calculate E equivalent first. E equivalent is equal to E1 means 8 volt and R2 means 2 ohm plus E2 means 10 volt, R1 means 1 divided by R1 plus R2, 1 plus 2. This gives 8 into 2 16 plus 10 into 1 10 divided by 3, which is equal to 26 divided by 3 volt. This is E equivalent. Then R equivalent for parallel combination. When cells are connected in parallel, R equivalent is equal to R1 R2 divided by R1 plus R2. These two formulas very important. This is the first one, this is second one. R equivalent is equal to 1 into 2 divided by 1 plus 2. R1 is equal to 1, R2 is equal to 2. This gives 2 divided by 3 ohm. Then current in the circuit. Let us calculate the current in the circuit. I is equal to, or current I is equal to E equivalent divided by capital R plus small r equivalent. Substitute the equivalent and R equivalent value and capital R value in this equation. Then we will get I is equal to E equivalent means 26 by 3, 26 divided by 3 divided by capital R. Capital R is equal to 20 and plus R equivalent. R equivalent is equal to 2 by 3. 2 by 3. I is equal to 26 divided by 3 whole divided by, this will become 60 62. 20 into 3 60 62. Take LCM, 62 divided by 3. These two will get cancelled. Then I is equal to 26 divided by 62. Then I is equal to 0.419 ampere. Approximately I is equal to 0.42 ampere. Okay, check the answer once with a calculator, no problem at all. Then potential difference across 20 ohm resistor, 20 ohm resistor is V is equal to I into R formula. Then V is equal to I value 0.42 into R value 20. Okay, this will become 84 and 10 8.4. So V is equal to 8.4 volt. And the next question, this is very important but quite different. Look at the question. The terminal potential difference of cell connected to an external resistance of 4 ohm is 2.4. When a cell is connected to 4 ohm, the terminal potential difference is 2.4. When the same cell is connected to external resistance of 9 ohm, the terminal potential difference is 2.7. Then we have to find EMF and internal resistance. There are two cases in the question. Let us consider first case. Case 1. We know the terminal potential difference formula. Terminal potential difference V is equal to I into R. We have to write this equation in terms of EMF. Look at this one. V is equal to I means E divided by capital R plus small r. We know this formula into, this is I equation into capital R. Since I is equal to E divided by capital R plus small r, right? And substitute the value for the first case. What is the terminal potential difference for the first case? 2.4 volt, right? So 2.4 volt is equal to E, we have to find out E value, and R is 4 ohm, external resistance is 4 ohm, plus small r, we don't know E value and R value, we only find that one, into capital R means 4. By the cross multiplication, we can write like this. 2.4 into 4 plus R is equal to 4 into E, 4E. Equation number 1, or cancel this one also. Okay, 4 ones are 4, 0.6 times. Okay, 0.6 into 4 plus R is equal to E. Let us consider this is equation number 1. And case 2. For case 2, terminal potential difference, new terminal potential difference is 2.7. So 2.7 is equal to, that is V value, is equal to E divided by capital R. For case 2, capital R is 9. 9 plus small r into capital R value 9. By the cross multiplication, we will get 2.7 into 9 plus r is equal to 9e. So this value into this one, 2.7 into 9 plus r is equal to 9 into e, 9e. Okay, cancel this equation. 9 ones are 9, 0.3 times. Okay, 0.3 into 9 plus r is equal to e, equation number 2. Okay, divide equation number 1 and equation number 2. 1 divided by 2. Equation number 1 divided by equation number 2. Equation 1 means this one, 0.6 into 4 plus r. 4 plus r is equal to e. And equation number 2 divided by equation number 2 means this one, 0.3 into 9 plus r is equal to e. E will get cancelled. 0.3, 2 times will get cancelled. This will become 2 into 4 plus r divided by 9 plus r is equal to 1. E cancel out, that will become equal 1. By the cross multiplication, 2 into 4, 8. 8 plus 2r is equal to 9 plus r into 1. Okay, and take the r to the left hand side. This will become 2r minus r is equal to 9 minus 8. So that r is equal to 1 ohm. This method is easy. If you divide like this, you will get a decimal point that will become complex. Substitute the r value in the first equation. That is 0.6 into 4 plus r is equal to e. So 0.6 from equation number 1. From equation number 1, that is 0.6 into 4 plus r. 4 plus r. R means 1. 4 plus 1 is equal to e. Right? So 0.6 into 5 is equal to e. 0.6 into 5 is equal to 3. That is e. So e is equal to 3 volt. This numerical is very important. Try to practice all these numericals in this video. Then you will get good idea regarding to combinations of cells and resistor combinations also. Thanks for watching.